Okay, we are given a beam that has a negligible mass and thickness, which supports this uniform block. It's pinned at A, and it rests on top of a post, which also has a mass. And we are to determine the coefficients of static friction between B and C. Okay, as always, draw your free body diagrams, one for the beam and one for the post. I'm just going to move this to make some more room. Okay, so I always start these questions by writing out the forces in the x, y, and the moments in the z, and setting them equal to 0 for each diagram. So I'll start with the beam. We have in sum of the forces in the x must equal 0, and that's going to be force B minus AX. Forces in the y going to be AY plus NB minus 1962, which is the weight. And we'll take the moments about the z-axis at point A. That's just going to be negative 1.5 times our weight plus 3 times NB. Okay, do the same for the post. So in the x direction, we'll have 4/5 times P minus FB minus FC has to equal 0. In the y, we're going to have NC plus 3/5 times P minus our normal force at B minus the weight of the post. And the moments, I'm going to take the moment at point C here. That's going to be 1.75 times force B minus 4/5 times 300 times the distance. Okay, we have 6 equations, and I believe we have 6 unknowns, which are AX, AY, force B, normal B, force C, and normal C. So that's 6 equations, and we have 6 equations here, so we can set up a matrix if you want. You can also just solve for B using equation 6 here because that's the only variable, but I'm going to use a matrix just for fun. So the matrix would look something like this. So all I did here was so our -1 came from our AX, there's 1 for the B, and the rest are all zeros, and you just do the same for the rest of the 5 equations. Okay, if we plug this into a calculator, we get that FB is equal to 102.86, and you can verify this by just using equation 6 and finding FB. The normal force at B is 981. Force C is 137.14. normal C is 997.2. And then since we know slipping at B and C occurs simultaneously, we know that this equation must be true. These two equations. Since we know FB and C, oops, that's supposed to be a B. But since we know FB and NB, we can solve for mu B, and same for this equation, and that just gives us 0.105 and 0.138.